Okay, so last night's homework, in my head I always say I'm not going to start my sentence with right okay and then I start my sentence with right okay. Have you ever counted them? Yeah, you lose count after about 167. Right, okay, see, there I go again. Right, I go again. I actually can't. Yeah, right. Oh! Okay, I'm going to start a sentence without saying right. It's really hard. Homework was, what was it? 2, 4, 6, 8? No, I can't remember. 2, 4, 6, 8, 10? Yeah, right, okay. Does anyone need... Stop! This is all recorded, by the way, so you can laugh later. No, number 2. Does anyone need number 2 done? Number 4. I'm trying really hard. Number 4? Number 6? Yeah. I nearly said it. Right, number 6. A square sheet of side 12 centimeters has 4 equal corners cut out. So look. So it's a square, okay, so it was 12, okay, so the side was 12, but there's an X cut out at that side and there's an X cut out at that side. So it's now 12 minus 2x, would you agree? Okay, this way there's an X cut out at there and there's an X cut out there, so it's a square, so it's 12 minus 2x. And the length of this line here is just x, isn't it? Okay, are we okay with that? Okay, so it says express the volume. So when you fold up those flaps, right, to get the volume, it'll be a rectangular box, so it's length by width by height. Okay, so that would be 12 minus 2x multiplied by 12 minus 2x multiplied by x, right? So I'm going to multiply into the first bracket with the x, so that would be 12x minus 2x squared into 12 minus 2x, just to multiply out. Okay, so multiplying out, that's 144x minus 24x squared minus 24x squared plus 4x to the power of 3. Did I do that right? Okay, tidying that up, that's 4x cubed minus 48x squared plus 144x. Is that okay? Have I made a mistake in there or anything? No, I'm okay. People got that? Okay, that's the volume, right? Okay, then it says show that the volume, right, of the box is a maximum when x is equal to 2. So that means you get dy dx, or in this case, what will I call it? dv dx, right? You get dv dx and you let it equal to 0. So when I differentiate here, I'll get 12x squared.
Yes, when you were multiplying in by the x, were you not meant to get 12x? There. No, second one.
Oh, well, I multiplied that by that. So I multiplied the x by the first bracket. So, and then multiplied the answer by the second bracket. Am I okay?
Yeah.
Right. Okay, 12x squared when you differentiate minus 96x plus 144. Right. And to maximize that, you're getting a turning point, so you let that equal to 0 and you solve. Everything divides by 12, which will make getting the factors easier. Minus 8x plus 12 equals 0. 2 sets of brackets, x and x, 2 and 6, a minus and a minus. Let each bracket equal 0, x is equal to 2, x is equal to 6. So I proved it's got a turning point at x equals 2, but I have to prove it's a maximum, right? Okay, so you can get the matching y values and then use your diagram to figure out which one's up high and which one's down low. Or you could get d2y dx2, which is what I do just for the experience of it. d2y dx2, so differentiate here again, you get 24x minus 96, right, sorry, I forgot the x, 24x minus 96, so then you put in the 2, 24 times 2 minus 96, which is minus 48, which is less than 0, which means it's a maximum. I don't need to do anything with the other one because they didn't ask me. Is that alright? Are we okay with that? You could alternatively have filled in your 2 for x into the original equation, 6 for x into the original equation, got your points, and figured out which one's up high, which one's down low. Is that alright? Is that okay? Right, are we good? Number 6. Number 8?
Yes, please.
Right, okay. Number 8 reads, the given diagram shows a line 3x plus 4y equals 12 containing the point xy. OAPD is a rectangle. Express the coordinates of P in x only. Right, okay, so I'll just do a quick sketch because it's handy. Okay, so I have this, then I have a rectangle, and then I have, this is P, and this is A, P, B, O. Okay, so I know this is x, y. I also know it's on the line, P is on the line 3x plus 4y equals 12. So I want y in terms of x. So that just means leave the y, leave the 4y even, move the 3x over, it's 12 minus 3x, and then divide each side by 4. And you'll end up with y is equal to 12 minus 3x over 4. Is that okay? Right. So instead of writing P as xy, I can write P as x times 12 minus 3x over 4. Is that okay? And then it says, express the area of the rectangle in terms of x. So the area of the rectangle is length by width. Agreed? Right. The length is the x coordinate, isn't it?
Excuse me, please, would Aoife O'Neill come to reception now, please? Aoife O'Neill.
So the area of that rectangle is length by width. So length multiplied by width. I'll just use a dot so it doesn't look like an x. Right, the length is the x coordinate and the width is the y coordinate, right? Because it's across x and up y. Right, 12 minus 3x over 4. Multiplying into that bracket, you'll get 12x minus 3x squared over 4, and that's an expression for the area of that rectangle. Is that okay? Right, then it says find the value of the area to maximize the area. Okay, so we're looking for the maximum. That means we're looking for the turning point. Right, okay, so we need to differentiate. Okay, get dy dx, let it equal to 0. Okay, so I'm just going to rewrite that as that's 3x minus 3 over 4x squared. So I just divided each term by 4. So 4 into 12 goes 3 times, 4 into 3 doesn't go, so I'll just write it as 3/4. Yeah, bye-bye. Yeah. Can we go with you? Tell me you're going somewhere horrible like the dentist.
I'll go to the optician.
Yeah, you can still go. Yeah, I don't want to go anymore, change my mind. Right, 3x minus 3x squared over 4. I'm going to let that equal to 0 because dy dx equals 0 at the turning point. Are you all with me? Right, okay. Multiply, get a common denominator. Common denominator is 4. That's over 1. 1 into 4 goes 4 times 4 by 3x. 4 into 4 goes once, 1 by whatever is above the line. And it still equals to 0. Right, so I don't need to, I can drop the common denominator now. I've evened up both sides. Can I move it up? I haven't cut anyone off, have I? So you get 12x minus 3x squared equals 0. You need to solve that. So to solve that, I'm putting the 3x squared first and I'm changing the signs. Minus 12x equals 0. I'm taking out an x, so I'll get 3x minus 12 equals 0. Let each bracket equal 0, x equals 0. That's not an answer, because when x equals 0, sure, the rectangle wouldn't exist, sure wouldn't. Right, okay, and the other answer is 3x minus 12 equals 0. So when you solve that, you get x is equal to 4. Right, and hence find this area. So that's obviously a maximum. Right, okay, because the other one isn't, the rectangle wouldn't exist. Right, okay, and it says find the maximum area. So my formula for area was back here, 3x minus 3 over 4x squared. So fill in the 4 for x, so it's 3 times 4 minus 3 over 4 times 4 to be squared. Right, and that's not working out right, because sure, here I filled it into the differentiated thing, didn't I? Not the actual area, did I? Yeah. No. Did I? Why am I getting 0? It's 12x minus 3x squared, all divided by 4. So that's 12 times 4 minus 3 times 4 to be squared. I'm getting 0. Why am I getting 0? There's something wrong somewhere. Did you get x is 4 as a max? No. Did anyone get this far? I'm after making a mistake somewhere. It's probably just a sign mistake somewhere.
I thought minus 3 over 2 as the x equals that, but I'm not sure that I did it right.
No, I don't think that would be right either, because it's negative. Right? Yeah. So yeah, I'm after making a mistake somewhere. Right, okay, so y is equal to 12 minus 3x over 4. That would be, yeah, x can't be 4 because it would work out being 0. And
it says that the area is x over 4 by 12 take 3x. That would be
x over 4.
And then by 12 take 3x.
12 takes 3x. Isn't that what, yeah, that's what I have, isn't it? As in x over 4, that would be 3x minus, yeah, I have the area right. So why is the maximum area, when I work out the maximum area, why is it turning out to be 0? Do you know, because there's no way the maximum area can be 0. Do you see my problem?
Excuse me, would Aoife O'Neill come to reception now, please? Aoife O'Neill.
Leave it with me. Right, does it say at the back of the book that find the value of x, does it say x equals 4 at the back of the book?
It says x equals 2.
X equals 2, so I've gone wrong here somewhere. Right, okay, so when I differentiated, did I go wrong when I differentiated? When you differentiate that, I'm quite confident this is right. Okay, 3x, so differentiate that. Oh yeah, when I differentiate that, you just get 3. Sure, here, look, I never differentiated it. Yeah, I never differentiated it. I just went and let it equal to 0. Right, okay, you know when I got the area, so the area equals 3x minus 3 over 4x squared. It's written differently at the back, but if you multiply into the backs, if you multiply the brackets, you'll get what I have. Right, okay, I forgot to differentiate to maximize. Okay, so I have to differentiate that, and I'll get 3 minus 6 over 4x, isn't that right? I let that equal to 0, so minus 6 over 4x plus 3 equals 0. So that means minus 6 over 4x plus 3 equals 0. Sorry, why am I writing the same thing again? So that's equals minus 3, and then you divide x is equal to minus 3 divided by minus 6 over 4, which will work out to be 2. Is that alright? So I forgot to differentiate. I know I did something stupid. right? Okay, so, and then you sub that 2 back into the area formula, right? Okay, so sub it back into 3x minus 3x squared over 4, and sub in x is 2, so that would be 6 minus 3, which would be 3. Is that okay? Right, if you sub the 2 back in there. Okay, sorry about that. Are we good? Did I confuse you more than anything? Right, yeah. Okay, so I got the area, then I differentiated, because I forgot to differentiate it, I just left it equal to 0. So then you want to maximize the area, so you differentiate it, let it equal to 0, solve for x, and then find out what the maximum area is by subbing that 2 back into the area formula up above. Right, okay, are we okay? Sorry. 10, am I doing 10? You're never going to ask me to do a question ever again, are you? 10, am I doing 10? Yeah. Right. The sum and height of the base of a right circular cone. So right circular cone is a cone. And a right circular cone means there's a right angle you can draw. So that's the height of the cone and that's the radius of the cone. There's a right angle triangle in there. Do you see that? Right, okay. So if you add the height and the radius, you get 20. Okay, that's what they tell me in the first line. If you write add the height and the radius of the cone, you get 20. And it says express h in terms of r. So that means h is equal to 20 minus r. Is that okay? Then it says for what value of r is the volume at maximum? I need the volume first. It's a cone. The formula for the volume of a cone is 1/3 pi r squared h in your log tables. Okay, so it's 1/3. I need to get rid of that h. So instead of that h, I'm going to put 20 minus r. Okay, so multiplying into that, it's 20 over 3 pi r squared, right, minus 1/3 pi r cubed. Just multiplying into the bracket. Is that okay? Right, I need to maximize that, right? So to maximize it, you differentiate it and let it equal to 0. So I differentiate that, I call it dv d what? What do I call it? dv d what? What's the variable over here? There is no x's. So dv d r, right? Okay. So bring the power down in front. So that would be 40 over 3. Remember pi is just a number times r minus, bring the power down in front. 3 by a third is 1 pi r squared. Is that okay? So then I need to let that equal to 0. So that's 40 over 3 pi r minus pi r squared is equal to 0. So I need to solve that. Okay, I can divide everything by pi. Right, okay, so divide that by pi, the pi disappears, divide that by pi, divide 0 by pi, you just get, so I'm doing this to the whole line, I'm dividing each term by pi. So I'm going to change the sign, so that's r squared minus 40 over 3r equals 0. To solve that, I take out an r, so r into r minus 40 over 3 equals 0. So that means r is equal to 0, which means the cone doesn't exist, so obviously that's not an answer. Or r minus 40 over 3 equals 0, so that means r is equal to 40 over 3. So the radius is 40 over 3, and it says that's all. It said what value of r gives it a maximum? Eve. Yeah. Right, are we good? Right, that's as far as I have to go there. I'm giving you more of those maximum minimum questions for homework, but I'm also moving on to the next section. I'm booting it now, but we're about 3 weeks behind where I want to be. Okay, so that's why I'm going quite fast at the moment. We have to get on top of things, okay, because we'll be worse for wear next year if we don't. What was I going to say? I'll be finished. There's 2 sections left in this chapter. I'm doing the second last section today. I'm doing the last section tomorrow. Monday I will correct all the questions on the last section. Tuesday we'll do some revision questions. Wednesday you're doing a test, and I'm giving you an actual test because I've given you worksheets the last 2 times. Okay, and the worksheet from the other chapter is due tomorrow. Okay, so test on this chapter on Wednesday. Which is first class on Wednesday, so at least be out of the way. Right, okay, is that right? Okay, and I have to give you a test because I can't do any more worksheets because you really need to do a test for me. Right, is that okay? Right, okay, so I'm going on to the next section, which is called the rates of change. Right, rates of change. And guess what rates of change mean? Guess what they want you to do when they're talking about the rate of change? You'll never guess. Rate of change, differentiate. Okay, so if you see the words rate of change, you differentiate. So up to now, we've been doing dy dx. That's the rate of change of y with respect to x. So it's the rate of the change of the top letter with respect to the bottom letter. So that would, the equation you get would be y equals all the x's, right? So it's the rate of change of y with respect to x, and that's what we call slope in the coordinate geometry chapter, okay? If I had something like dr dt, okay, I just made up these letters, right? So that's the rate of change of what? Rate of change of r with respect to t. Okay, so it's the rate of change of the top letter with respect to the bottom letter. Okay, it'll make more sense when we see examples, okay? But just this is the language that's going to be used in this section. They're not going to say differentiate anymore, they're going to find the rate of change. So you need to know that rate of change is differentiate. Yeah, I was just looking, they've been on all day. Yeah, would you mind? And no one asked me to turn them off, and they've been on all day. So this will make more sense when we see examples. Okay, it just won't be dy dx anymore, and I've kind of started introducing it in the last section. It won't be dy dx, it'll be dr dt, dA, dv, stuff like that. Okay, right? So it's not going to be dy dx anymore, we're just using different letters. But the minute you see the words rate of change, you differentiate. Okay? Okay, and I'll explain what this means in a minute when you're finished writing. Okay, right, so rate of change, okay, there's a special area where we have to zone in on, and the special area we have to zone in on is motion, okay, so anyone who does physics will be used to these words, okay, So in the study of motion, the variables are, right, in the study of motion, we talk about distance. Another word for distance is displacement. And it's really annoying because they always use S to denote distance, okay? So S is not speed, S is distance, okay? Right, they'll talk about the speed, or another word for speed is velocity. It's not strictly speed, but we just need to, in maths, it's the same thing, okay? Right, so I don't want any physics people contradicting me. They're not the same thing, but they are in maths, okay? So, and that's usually denoted by the letter V, right, okay? And then we're also going to talk about acceleration, which is A. How does that relate to rate of change? The rate of change of distance with respect to time is your speed, right? If you think how quickly you change distance is your speed, and how quickly you change your speed is your acceleration. Would you agree? So the rate of change of distance is speed, the rate of change of acceleration is, or the rate of change of speed is acceleration. Okay, right, let's cut to the chase. What the hell does that mean? That means if they give you an expression for distance, you differentiate it and you have an expression for speed. You differentiate that expression and you have an expression for acceleration. Okay, so that's cutting to the chase. If they give you an expression for speed, or sorry, if they give you an expression for distance differentiated, you have an expression for speed. If they give you an expression for speed differentiated, you have an expression for acceleration. So basically, distance is denoted by the letter S. So if you go ds dt with respect to time, so ds dt would be speed, and then d2s dt2, second differentiation will give me acceleration. So this is distance, speed, acceleration. Distance, speed, acceleration. And again, when we see an example, it'll make more sense. Okay? Right, so I have lots of examples. Right, example 1. This is actually on page 126. It's question 1. That's supposed to be a Q. So the relationship between P and Q is given by P equals 2Q to the power of 3 plus Q, right? Find the rate of change of P with respect to Q when Q equals 4, okay? And I'll leave you write it down and then we'll do it. Yeah.
You know, physics, if we needed a shortcut, could we do that?
Yeah.
Oh, would it work?
Yeah. Yeah. Right, are you ready? Okay, so find the rate of change of P with respect to Q. What are they asking me to get? The rate of change of P with respect to Q. What is that in letters? D what, D what? dP dQ, isn't it? So dP dQ. So they want you to get dP dQ. So look, we have an expression for P. So all we're doing is differentiating. So what will I get when I differentiate that? 6Q squared plus 1. Okay? And I have to get this when Q equals 4. So what am I doing? Everywhere I see a Q, put in a 4. So it's 6 times 4 to be squared plus 1. So that's 6 16s. 96 plus 1 is 97, I think. Okay. I'm not confident of that though, so. Is that alright? Okay. So basically all we're doing is using different letters. We had dy dx before. Now we have to look at the question, recognise the letters. I want you to write this down. You don't have to. You don't lose marks if you don't write it down. But for the next section, it's going to be very handy. Okay? So will you practice writing that down when you're differentiating and stuff? It's very handy for the next section. It's not necessary, but it's good experience for the next section. Is that right? Okay. Are we all fine with that? Example 2. Right, which is page 126, question 3. So the area of a circle is given by area equals pi r squared. Find the rate of change of the area of the circle with respect to r when r is 5 and when r is 10. So again, I'll leave you to write it down and then we'll do it. Hurry up. Hang on a second, because this is recording.
I can bet you.
Yeah, I'll yeah, just in case. Yeah. Right, okay, so the area is given by A equals pi r squared. So the keywords here are find the rate of change. So I won't give you a break. I'll give you a break in a while. I'm going to finish this bit and then I'll give you a break, okay? So the rate of change, what does that mean you're doing? What does differentiate? So those 3 words means differentiate, okay? So when I differentiate this, what will I call it? dA dr. So it's dA dr. So you're differentiating A with respect to r. That just means it's all r's over here. Differentiate pi r squared. Bearing in mind pi is just a number. Right, what would it be? 2 pi r. Bring the power down in front, reduce the power by 1. Okay, 2 pi r, right, okay. And then for part 1, when r is 5, replace the r with a 5, so that's 2 pi multiplied by 5, which is 10 pi, that'll do me, as in, that'll do as the answer. They didn't say correct however many places decimals, so that'll do fine. And the second part is when r is 10, that just means everywhere you see an r, put in a 10, so it's 2 pi times 10, which is 20 pi. Right, are we good? Example 3. Right, okay. Are you ready? Scream if you're not. So this is page 127, question 5. You may notice I'm doing all the odd numbers. What do you think you're getting for homework? The even numbers, yeah. So it's pretty long. Again, I'll leave you right and then we'll talk. The population P of a new housing estate T years after a certain date is given by the formula P equals 100 times 5 plus T minus 0.5 T squared. Find the rate of change of the population after 3 years and explain your answer. That's 5 plus T minus 0.5 T squared. Or the writing's kind of a bit funny, I think.
Sorry, would you mind if we had Roshan and Aoife lines?
No.
Do you have both?
Roshan and
Right, for 2 seconds.
Aoife Dillon, is it?
Or her sister.
Oh, right, okay.
Thanks for it. 2 seconds.
I forget there's 2 E. Right. That's 5 plus T, 5 plus T minus 0.25 T squared. Okay. Right, okay, are we ready? Right, okay, so I want the population, there's a formula, right? I want the rate of change, so what does that mean they want me to do? Differentiate. So they're the key words you need out of that question. Rate of change means I differentiate. I'm going to multiply into that bracket before I differentiate, right? So that would be 500 plus 100t minus 25 t squared. Is that okay? Now I'm going to differentiate. So what I call it when I differentiate it? dp dt. dp dt. The rate of change of population with respect to time, and they told me time is in years, right? Okay, so differentiate over here. What do I get when I differentiate over here? 100 minus 50t. Agreed? Okay, and I have to find that when t equals 3. So what will I do? Everywhere I see a t, put in a 3. So that would be 100 minus 50 times t, which is, 50 times 3, which is minus 50, isn't it? Okay. Put that in the context of it says explain your answer. So put that in the context of your question, right? Every year, right, okay, the population is increasing or decreasing? Decreasing. How do you know decreasing? Because it's minus. It's decreasing by 50 people. So every year, the population goes down by 50 people. So that's explain your answer. I'll leave you write that. So every year, the population decreases by 50 people. Are we good? This is the last example now. I know you're tired writing. Okay, this is the last one. Right, so this is the one with the distance and the speed and the acceleration in it. Okay, right. So the distance, so this is page 127, question 7. Right, okay, so basically we have distance. So they've told me what distance is. Remember, S stands for distance. Very confusing, but S is distance. So distance equals 2t squared plus 3t minus 4. Differentiate distance and what you get. Differentiate distance, you get speed. So differentiate that. And what I get when I differentiate? 4t plus 3. Right, and then differentiate speed, then you get what? Acceleration. So differentiate acceleration and you'll get 4. Right, and they said find 1 the speed and 2 the acceleration when t equals 4. So the speed when t equals 4 equals 4 times 4 plus 3, which is equal to 90. And look, how can I fill in here? I can't. The acceleration is always 4. Right, okay, so it doesn't matter. The acceleration is always 4. Right, because I can't fill in for t because there is no t. Right, so that means the acceleration is always 4. Is that car getting, or car, whatever it is that car getting faster or slower? Is it speeding up or is it slowing down? Speeding up, isn't it? Why? Because the acceleration is positive. If the acceleration turned out to be negative, right, and it does, that means it's slowing down. Okay? Right, so I know whatever this is, car, bicycle, whatever it is, it's definitely speeding up because the acceleration is positive. Right? Are we good? Right, okay. Work for the rest of the class. You can have 5 minutes off, right, and then you're going to come back and do that. Okay, so the 5 minutes off, it's 14:36 now, so I'll tell you at 14:41 to get working.